Welcome to How Dlang Improves My Modern C++ and vice versa. Great to see everybody, whether you're in the audience here at ACCU as we're kicking things off or virtually. Hello, everybody. Great to see everybody. Today, we're going to have a nice talk here introducing what I think will be new for many folks, the D programming language, but also talking a little bit about C++ and how these two languages complement each other. So I hope you'll enjoy. Feel free to ask questions at any time. We'll have a microphone running around, or I'll try to repeat questions the best I can. And there will be some interactive prompts as well, because I want to hear from you folks as well as we're just starting off this conference here. So my name is Mike Shah, and I'll introduce myself in a little bit here. But we've got a nice 90-minute session here, so let's go ahead and get into it. And again, I'll show this QR code if you want to follow along. Otherwise, I'll also take participation by hand, whichever you are comfortable with. So I want to just go ahead and, as I mentioned, kick things off with a little interactive exercise and talk about the D programming language, just a first impression. And maybe just by a show of hands, how many folks have heard of the D programming language? Okay, so we got about, that's probably like 95% of the room. How many folks have used the D programming language? Okay, a smaller handful. So about a handful of the audience members here. So let's go ahead and just take a peek at it. So we've definitely heard of it, right? We know D comes after C++ or so on. Just a little pop quiz here. Just take a moment, a minute, 30 seconds to look at this code and try to figure out what it's doing. And I'll let you think about it as I look at my timer here. All right, what do you want to raise a hand and shout out something that looks interesting or take a guess at what's going on in this code? I heard something about sorting. I heard someone say it sorts an array at compile time. Must have been one of the folks who's used D before. Very good. What else here? Anything else jumping out? Compile time. That's great. Let's go ahead and work with this here. So I'll give you a few answers. And if you look at the D programming language homepage, yeah, right at the top, the sample, sort an array at compile time. So perfect, A++ for you folks. And what's kind of interesting about this, just to look at some of the examples, is of course we've got this import statement here, bringing in the standard libraries that we can use. You'll notice it's within main, so we have some sort of scoping that we can use. Line 5 shows what I'm going to introduce later is universal function call syntax, where we could have a string and then dot, so it can sort of flip the order of the arguments there, so it reads well left to right, which is often very readable and very nice. Line 7 has an enum. Enums must be known at compile time, so we're setting up this array here of numbers, which are just set up with brackets. And then line 9, we have an immutable value here, so that's not going to change at all. So immutable, usually a key for doing computations at compile time, and we're able to just call a regular sort function. So there's no special compile time or any magic with that sort function. It'll just sort the list, or the array, excuse me. And then the pragma here will print out finished compilation when we just compile the program with the sorted array. Then when we actually run this program, it's just going to print out starting program, and that's it. So it's kind of amazing, some of this stuff at compile time, and we're seeing a lot of this type of work in C++ coming in as well. So I'll ask sort of the same question that I started with. How many folks have programmed in C++ on this audience? And this is, I think, every hand in the audience here. So, that's the crowd. That's sort of the expectation coming in here. But we'll look at things from a D perspective along the journey. So again, why you might care about some of these things, D's trying to compute as many things at compile time. That's usually good for performance. And it just looks like regular code, which is often also a good thing. There's ways that you can check to see if something executed at compile time, of course. But you want to sort of know what's going on runtime versus compile time, and again, squeeze out as much performance as you can. Okay, so that's just a little fun exercise to get us started here. I'll introduce myself. Again, my name's Mike, and primarily my role is teaching. So I teach, day to day. I do consulting and various technical training, and I've had it passed as a graphics programmer, and occasionally I'm still doing that type of stuff. So anyways, you can learn a little bit more about me and check out some of those resources as you have time. The code for this talk will be posted at this GitHub if you're interested in playing around with any of the snippets or sharing with your friends. Just a note on that. And of course, the abstract that brought you here. So thinking about the D language here. And usually I don't give talk outlines, but I figured we should still have a roadmap since we've got 90 minutes together here. But really, I want to break this talk down into 3 different pieces. So I'm going to give a little bit of thoughts on programming languages and hear from you folks also some of your thoughts. Then I'm going to give you a D language preview so we have some tools, and for the other 90% of the audience who hasn't used D before will understand why maybe it's an interesting language, or maybe why it matches up with another language that you're using. And then I'm going to talk about how C++ and D have complemented each other by knowing both or exploring 2 languages, which is really the central idea or the thesis of this talk, that learning more than one language and trying to master more than one can often benefit you in your day-to-day programming. So, getting started with thoughts on programming languages. Dlang versus C++. Okay, so here they are about to battle. Okay, not quite. Not quite that talk here, okay. So this is going to be a little bit more accurate of today's talk, D language and C++ here. And of course, there's tons of other languages you could substitute for which 2 you want to choose here. So just speaking about programming languages a little bit here, I'm a bit of a programming language enthusiast myself. I've played around with lots of different languages. I've used various ones in various professional or research capacities. Here is a range of them. But I've explored these languages by choice, again, just because I think programming languages are very interesting. The different ways that you can think about approaching a problem, the different sort of ways that they're optimized to solve different problems in different domains. So many of you have probably, again, used one or more of these programming languages. Maybe multiple languages you're using day to day. Maybe you're using C++ with Python to script or automate some activity. Or writing a library in C++ that you call from Python, for example. Maybe you're just required to use some language for a specific platform. And I know you can use Swift on any platform you want, but it tends to be used on iOS, just as an example, or Kotlin for various devices. So maybe that's why you're using or choosing a programming language. Or maybe the domain you're using some language in is just dominated in that domain. So I see a lot of data scientists and bioinformaticians using Python and R, for example, for statistical analysis, or Julia, or all these sorts of different languages. And maybe you get to choose. Maybe you're lucky enough, you're running your startup, or you're a researcher, and you just get to choose the language. You're the boss, or you're working on some task that allows you to choose some other language of your choice. And I bet at some time, someone also said to you this when looking at programming languages. They said, you should just learn Haskell. So, it's just the right language. It'll, teach you how to think, and it's the best, and it's pure, and all these things. And, you should learn it. You should take a look here as we go through this talk. But the question is, again, why here? So I want to give us a little activity here. Again, if you'd like to participate, you can scan the QR code or go to slido.com and enter this number here, 2649488. Folks online, feel free to participate as well. I just want to hear from you, why should you learn a programming language? Why are your friends telling you to learn Haskell, or I'm telling you D is an interesting language? And we'll put these up on the live here. Let's see folks' responses. I'll just read some of these as they're coming in. Exposure to a variety of programming paradigms and idioms. New idioms, new ways of thinking. Perspective. Extend horizon. And better understanding paradigms of problems that can exist. Functional. Become a better C++ programmer. monads, different perspective on problem types, curiosity, why not? Love that. Yeah. Ranges, okay. Have fun. Yeah, see how to approach different problems in different ways and broadening your perspective. To show off, yeah, sometimes. I speak 20 programming languages, right? And then finding the best tool for the job, yeah, thinking about maybe the domain that we want to use it in. Laziness and streams, again, maybe thinking about different features that we use. This is great. This is great. Okay, so I'll go ahead and close this poll off. We'll have another one here in a moment that I'll activate in a few slides here. Okay. So, competing with this talk right now, you can find some more answers to that. Francis is giving a talk on the benefits of learning different languages. And I suspect you're going to hear a lot of those different things as well throughout that talk. So I encourage you to watch that on the playback after this one. So for me, the past few months, I have been doing this experiment and documenting it. I've been spending about 1 hour or so with every programming language that I can think about, every one that somebody's told me I must learn and have to try out. And in particular, I'm trying out languages that are new to me. So Go, V, Rust, Zig, Free Basic, Free Pascal, Ruby. Some of these I've used before. Some of them I'm revisiting after 10 years, so it's like a new thing to me in my memory. But again, the point of this exercise is to, again, go through that process of expanding your horizon, right? Learning new paradigms and idioms in different languages. But one important thing that I'm going to go through this talk, as I sort of alluded to at the start, is this isn't a language versus language talk. So I'm not going to pick the better of two languages. Maybe I can do that privately if you want. Everyone's got their favorite. One of the reasons I'm not going to do that is there's a really good talk by Dan Sachs from CPPCon in 2016 who says, if you want to remember just one thing from his talk, when it comes to persuasion or trying to learn something new or tell your colleagues, hey, maybe we should try this thing, if you start arguing, you're losing. So I'm not going to argue for a language today. But I am, again, going to tell you why learning one other language is going to help your C++ or whatever else you're doing. Okay, so you're going to have to be motivated enough to want to decide, that you want to answer that question of which language is better. You'll answer that yourself. So that's from me. And again, I personally think new languages help you think about concepts more efficiently in your default language, whatever that might be. So with that said, time for another little poll here. Feel free to chime in here. Can you recall one concept you've learned in another language that you have applied to, say, C++ or another language? So you could put language and then idea. For example, someone put laziness and streams. Where did you learn that from? Well, let's see what live answers are coming in here. Rust, ownership. Great. Monads again. Must be our Haskell programmers. Functional programming ideas. Okay. Yeah, I wonder which language. A few folks typing more. The ideas behind functional programming? Yeah. And we've seen some of those starting to trickle into the C++ language itself. Right? ML, yep. The SML OCaml family. Scope exit, yeah, great. That's a great feature of D and other languages. Async await, sure. Could be in JavaScript, for instance. List comprehensions, maybe from Python or Lisp or some of these. Yeah, great. Great list here. All right, let's go ahead and I'll stop that poll here. And we'll get back into it. All right, so I do have one sort of goal through this talk, something that I'll just put forward though. If you are just going to remember one thing, my sort of art of persuasion is to go ahead, set a timer, go to the D language homepage and just try out the tour. Same thing I've been doing. You can see me do it on camera over and over and over again. I do the same exercise to get started with a language. If I've successfully done my job with this talk today, you'll be curious enough to curious enough to try out the D programming language. And you can watch how I do that on the talk below. At the very least, doing this exercise might just help you empathize a little bit with your junior engineers who are starting from scratch. Again, putting yourself in the beginner's shoes and just seeing how things go and what it is to be a beginner again. I think that's always a valuable exercise. All right, so with that said, that's a little bit of the thoughts of programming languages. Now I'm actually going to give you a preview of the D language. While D is similar to C++ in many ways, it is its own language, so I want to give this common ground here and just see how the D language works. So I'll go through some slides, I'll highlight some things, I'll move faster or slower depending on how our questions go. And feel free to ask any questions as they arise. All right, so looking at the D programming language, what is it? What exactly is this language? Well, described from their website, it's a general-purpose programming language with static typing, system-level access, and C-like syntax. With a D programming language, you write fast, read fast, and run fast. All right, sounds like great things to me. But again, it's going to be something very familiar. It's in the C programming language family, so you can probably look at some D code like we did at the very start and understand what it's doing. It's a systems language, so access to pointers, memory, low-level stuff, and static typing, which maybe we often associate with safety and type safety. So a little bit of history on the D programming language. Right there on this right-hand side picture is Walter Bright. In the middle of the photo, there's me being goofy. But he's the creator of the D programming language. But he's a good figure to know and to read some of his papers. He's done a lot of work writing C. He wrote one of the first C++ compilers. He's done some game design work, but most famously these days, he's known for the D programming language, which he started in 1999. So D's been around for quite some time. I imagine for folks who said they've heard of it, caught wind of it at some point, maybe in this era, 1999 to 2006, or later on. And that was the D1 version of the compiler. So again, similar to C++, a language going through evolution, D is as well, just like any language that's alive and well. Now, around 2006 or 2007, a name that C++ folks may surely know is Andrei Alexandrescu, also joined the D project and started contributing heavily during that time through 2019, and they're still on the foundation together. So that's a little bit about the history there. So D itself is 25 years old, and it's been steadily evolving and growing to the point where there's actually 3 compilers. You've got the official compiler called DMD, which stands for the Digital Mars D compiler. That's what the language was originally called. And folks just insisted to call it C++ because it looked like, or excuse me, to call it D instead because it looked like the next evolution of what C++ was. And D's ecosystem is very interesting because they have this very nice setup where you have this DMD compiler, the reference compiler that says this is what the language is, this is what it means to be correct, because it compiles very, very, very fast. So that's the goal if you want fast iteration times. And then you've got the GCC implementation called GDC, and then the LLVM or Clang-based compiler called LDC, and those are the compilers used to generate your optimized code. So you get this really nice development cycle where you compile in DMD, and then can run and optimize your code for different platforms with GDC and LDC. Tools are readily available to download for free. It's an open source project. And along with the download of the D compiler, you also get a package manager called Dub, the D package manager. You get some static analysis tools and code formatting tools like dformat and dscanner. And there's Visual Studio Code extensions, there's IntelliJ extensions, all those different things for the D language as well. D itself, where is it being used actively today? Here's a list of a few companies where it's been used previously in production. It's found some interesting niches in performance-based domains, gaming, for instance, image processing, finance, and so on. So I'll just show you a few pictures. It's sort of nice to look at. It's been used in AAA game projects, so games that you would find at your local store, or I guess you'd buy digitally these days, but AAA game Quantum Break was using D code for their animation system, so very performant stuff. So you can learn a little bit about that. It's been used in various game engines that are available in open source. Again, you could check those out there. Here's another game engine that was built that was quite nice by an independent developer. Here's another game engine that was recently displayed. Now they have a match game, but what was interesting about it in particular was that it was available for PlayStation, Xbox, Android devices, so many different platforms as well. So you can run D code everywhere with these different compilers. This is a tool for doing fluid simulations and gas simulations. So again, yeah, the question. Absolutely.
We saw this other place where they doing like the worst thing is less environments.
Yeah, so the question was about where is D displacing?
It's like it's
Which language is it displacing? Yeah, that's a good question. I wish I had exact data. I mean, I'm looking at some of these. So we do see it pop up in commercial games on occasion. The biggest proponent of D, I'm trying to see, I don't see them on this list, is Symmetry Investments, which is a financial trading firm. So they've done work with D because of, again, the stability. Funkwork is another big one, which works on trains in Germany. We've seen it showing up in data science more frequently. As we're going to find out, the D language, it almost looks like Python in many ways, but you get the static typing, you get the performance. In fact, that's where I'm pushing it a little bit more. And in the fluid and gas simulator, that was one of their decisions. D's also used, it's got a really nice web framework called vibe.d, which is being used for web applications. I have some lists of this somewhere of companies that are using it. But again, you could see on their website other domains. Now, if the question's about is D taking over C++ or are people using it instead of Rust or some other languages, that I don't have good data on. I think it comes down to this sort of preference. And, what we're going to find out with languages is once you like something, you kind of like something as far as languages go. It's about convincing maybe your team to try something new and be efficient in it and so on. Hopefully I'll give you enough evidence today to see that D might be a worthwhile choice if you're starting a new project. The other interesting thing that I'll note about D is it has a built-in C compiler. So you can just take any C code and compile it with a C compiler, and it mingles with your D code perfectly. So there is some work being done in operating systems. There's one or two that are being developed. So yeah, it's got a lot of potential in many different domains.
Thanks.
Yeah. Let's see, so just some other ray tracing. I use it in graphics and teaching. That is one place where it is displacing in my own teaching. I found students do an excellent job in the D programming language. I think it's actually an excellent first language. That's another talk that I'll link later on. So anyways, you can find out more. I list a few more projects in a different talk on the source code in those projects and why they might be interesting to study in my review of the D language here. So the D language itself has many, many different features making up the language. Again, it's a large language, like C++ is a large language. But that gives us many, many different tools to work with, which I think is very exciting. So it's got built-in dynamic arrays, associative arrays, or maps. The bounds checking for the arrays can be disabled or enabled as needed, lambdas and delegates, function or the equivalent of std function, the universal function call syntax, many different paradigms for functional programming, generic programming, object-oriented, parallel programming, and so on. And it's a garbage collected language by default, or you can turn that off and do manual memory management if you need for performance, like in the gaming examples. D also comes with batteries loaded, meaning it comes with a standard library. One of my things that I'm going to mention here is I think we need a little bit more of this in the C++ ecosystem. But it's been a little bit more liberal in bringing in more packages and so on in its library, which I think has been interesting to take a look at. So it's got containers, it's got data structures, it's got a large algorithms library. Ranges is sort of the default that they have available. And you'll find other packages for working with JSON data, CSV files, zipping files, sockets, networking, SQL databases, and so on. All that stuff's out of the box and ready for you. So with that said, that's very exciting, but let's look at some D programs here. Here's a little hello world. They get us started at the same spot here. Again, you'll see some familiar constructs here with import statements to bring in standard library. We've got a main function. It starts out with void, writeLine, and of course, the fully qualified name here for a standard IO, and then writing out the name here. And as I mentioned, you'll find that D incorporates very well with C libraries. In fact, all the C standard library is also available if you want to use that. Towards the bottom, if I draw your attention, again, it's a compiled language here. So you can just do DMD, the file name, and then the output of the executable, and run it as you normally would from the command line. The modules themselves can be scoped locally to functions. I found that this is helpful, and generally it's accepted as a best practice. Folks might have differing opinions, but generally it's accepted in the D community to allow for easier refactoring and keeping all of your functions and the scope of their imports in one function here. And then the other thing that I will note about this is what we're hoping for in C++, right, to get our module support fully available, right? So I know some of the compilers have this and are incorporating this more and more, but this is ready to go in D, and it's an advantage for the compilation speed. So there's another neat tool in the D programming language ecosystem called RDMD, which is just for running DMD. And this allows you to basically run D programs as scripts. So you could just run them with the RDMD program. If I draw your attention towards the bottom, you'll see there's RDMD in the file, and it just runs like a script. In fact, if you put at the top of the file the pound bank signal /bin/RDMD, it'll just run and execute as a script file, which is really nice. So this is one thing. Again, more of my personal projects, it's displaced all of my scripts. I don't use Python anymore. I use D, but again, that's why I'm giving the talk here, showing off my favorites. But it's actually quite nice to do this. So here's an example with the script here. If you just want to run and execute your files as D scripts. D, in my opinion, gets the defaults right. They've had time to learn from other different languages, meaning that variables have initial values. So every value is allocated unless you say otherwise. So that means you don't have to worry about garbage being in your memory. If you do, for performance reasons, want to not initialize some value, you can set it equal to void. I'll talk about that later, as I think there's been some proposals in the C++ community for that. But for safety, this is a nice feature. The primitive types are also well defined for their sizes. So an int is always 4 bytes. So you don't have to worry about, you know exactly what the data type is, which is nice on different platforms. So every data type has a property. Property basically acts as a field, but it's a function call, so you can check what the initial value is. You can set the initial value if you have your own default types. You can see the size, alignment, mangle name, and get a string value back. As I mentioned, D is a systems programming language. This means we get to work with memory. And D, however, by default, is a garbage collected language that is turned on by default. So for instance, if I draw your attention towards line number 6, you'll see a new here, and you won't see a delete. So this will be familiar if you've used Java or other languages. It'll eventually be cleaned up by a default stop the world collector. All right. D has pointers, same syntax as C. I could take the address of variables and work with them. So if you're creating data structures, no problem there. And here's just another example here. Now, when we're using this stuff like allocating memory and working with pointers, maybe pointer arithmetic, sometimes we have to be careful. So as I heard from today's keynote, we might want things like @safe or the ability to say, hey, don't do bad things here. So in D, we do have attributes. I'll draw your attention towards line number 4 here, where there's an @safe mark here, which means that we can't call other functions that might be unsafe, which is @system by default, which means, hey, we know what we're doing here, because there is some pointer arithmetic here. Okay, and that's considered something that could potentially be unsafe because we could add too many values and jump to an address that hasn't been allocated. So D in this way allows us to write safe code. There is also a borrow checker @live as an attribute. I don't capture it here, but just wanted to mention that since someone mentioned ownership and borrowing. So that is also available in the D programming language. That not a lot of people know about, but it's a new thing. Just as an aside, because D has the reputation of being a garbage collected language, you can still just malloc memory and take ownership over it. So no problem there, right? Just make a regular call to malloc, cast it to your type, exactly what you do in C. But again, you're responsible for freeing that memory. Okay, and you can use standard tools like Valgrind and so on to check for leaks at this point if you run into errors, because it's using the C library. And the benefit, though, with D is even while you're using some of these features from C, for instance, like mallocing memory, you can actually take slices, as I'll introduce here in a moment, or ranges, just like you normally would. So at line 8, I have a little example of a range here, but I'll explain that in another slide here. So there's a convenient way to access memory, bounds check it, and so on. And here's another sort of safety feature of the D language that I'll mention. I think, again, this was something else that came up in Herb's keynote. So nice transition here. But we do have scope guards as well. Folks might know these as defer in other languages. But in D, we can use scope exit. So I'll draw your attention to line 14 through 16, which is basically the same idea as resource allocation is initialization, where when we leave this scope here, we want to make sure we free the memory at line 6. So this will call it in a deterministic order. When we leave the scope of main, we'll make sure we free the memory. So very nice, very simple thing that we can do. And if you really want to avoid the garbage collection, what you can do is, again, put a @nodegc attribute on a function. So I'm looking at function at line 11 here on main. You could just put @nodegc, and that's a transitive property. So if main calls into some other function that calls another function, if any of those functions allocate memory, which WriteLine in this case does, right? It allocates a buffer large enough to print hello. That's considered, that won't compile. We'll get an error here. It says, main cannot call no GC function, and you need to use another function that doesn't allocate there, okay? So there's many other different strategies or summarizing how to take control of your memory. There's scope variables, there's reference counted things in the standard library. As I mentioned, there's an ownership system as well. So you get to take control here, which really makes D a nice language if you want to just use it as a better C. In fact, we're going to talk about better C, which is a thing in the D language here as well. In D, we have const as well, just like in the C programming language. So again, const makes things read-only memory. Nothing's changed there. But something that's even stronger than const is immutable. And immutable is truly read-only. So the difference is if you have something that's immutable, again, this is transitive. So if it is in a pointer that points to something, the data that it points to can never change here. And I'll show it in a brief example here. So again, If I'll draw your attention to line number 9 here, where I have a const pointer here. So I can point to some memory address where data is, and I can actually still change that data here. The pointer won't change what it's pointing to, right? That's the idea here. So we could still get away with that, but immutable is much stronger. So anything that I'm pointing to, the data truly can't change. So we like immutable, especially if you're doing concurrent programming and want something to be truly read-only. Again, this is a strength that was designed into the D language by making things immutable. And that's the default that we tend to opt into. Control flow stuff, pretty standard. You have your if statements, case statements, and so on. Again, since D focuses on ranges, which I'll introduce, we could do neat things like from case 0 to ... case 5. We can switch on strings, and again, a few little improvements there. For functions, we have local functions. So local scope is totally allowed in the D language by default. We can have lambda or anonymous functions are allowed. And we can use a short syntax as well for lambdas. So a few different ways to do things. We also have higher order functions. So you use the function keyword, similar to how you would use perhaps a std function or a function pointer in C and C++. So that makes the syntax relatively clear here for what this is, or what the parameter types are in the arguments for the type of function pointer. And then we also have delegates as well, if you want to capture surrounding members or variables. So if you have a member function and want to make it a delegate, you can do that, similar to other languages like C# and so on. One of the nice things about D that I've grown to appreciate a lot is the universal function call syntax. So this is the idea of just being able to put a dot after the function, and that treats it as the first argument. So you can be the judge here if you look at lines 8 and 9 and compare them to lines 15. Which one you think is cleaner? I would argue that line 15 is much cleaner, again, to read left to right with the universal function call syntax. And again, this makes me think of things like in design patterns, like a builder pattern for structuring your code that are just nice. But we get this out of the box in the D programming language. Here's just another example comparing line number 11, where I've got a function that calls a function that calls another function, and some arguments, versus line 15. You can see that in a one-liner, or I have a sentence that I want to strip the white space from, make it all uppercase, and replace Mike with Joe, and then strip more white space from it. And that's, again, just nicer to read. And it tends to be not only nicer to read, but from my experience, a little bit less error-prone when I'm following this code. All right, so there's a lot more on functions. Again, I'm not going to give you the full language, but there are ways to make functions lazy. You can memorize them if you want to save their state, but purity is important enough that it deserves a slide here, that I can make a function or mark it as pure and check that it doesn't have any side effects. So things like global variables or pointers into that function would make it impure, right? Because you could have a side effect. So that's pure. You can have functions that are also weakly pure. So for my functional people, meaning that the actual arguments you could pass in with a pointer and have them those change state, but the actual function won't change any other global state otherwise. So that's a really nice feature here. We get some other features like auto is available in D. So same type deduction as in C++ with auto, so that'll be familiar. So you can almost always auto if you like that. Although I tend to, well, I like that rule, I tend to be more explicit. So here's just some more examples of auto. I'll kind of move through here. And auto is smart enough to deduce things like, again, if you have auto p of x and point it to something, it'll figure out that this is a pointer to an integer. Okay, so you don't have to specify a little pointer by the auto or anything like that. For type creation, the equivalent in C++, we have decal type, but in D, you have type of. So you can just take the type of something, which reads nicely, and it'll deduce the type. And you can use that for a type declaration. So for templates, for functions, a little change in the syntax here from C++. Line 4, you'll see add. Then you'll see your template parameter list. So no angular brackets, just the same old parentheses. So you don't have to stretch your fingers out. And then we can see the template parameters and the regular function arguments here. Okay, so that's the idea. And you can use auto for the templated function, and it'll deduce the type here. Now getting into some more interesting stuff, D has had template constraints. We know these as concepts in C++, right, to be able to put some sort of constraint on the type. So you can do things like use the built-in traits to see, is this a basic type? And it's basically just an if statement here. Again, just some condition that's being checked here to make sure that that's true. And if that's true, then you can create or instantiate a version of this function here with any of the basic types here. And here's an example failing here. While string is highlighted, you might think it's a keyword. It's actually, a string is actually a immutable character array. So again, read-only, can't be changed, can't have any other data changing it. So you'll see the template, a little error message here telling you that it doesn't pass this basic condition here, this concept or this template constraint. And these can also work. You can put contracts, as I'll introduce here, for functions as well, to make sure that things are passed before we actually can use them. So we have static arrays, fixed size arrays, as you might imagine. These are stack allocated. They're bounds checked by default, but you can turn that off, again, if you care about performance. And we have dynamic arrays, which is a little bit more interesting to look at. These are basically your std vector, built straight into the language here. So you could use those, and any of the tricks that you've learned with vector for reserving memory ahead of time and all those different things also work here. We have associative arrays or maps built in to the language. So I'll show you an example at line 8. You can see we have a students here. The key is the integer, and the type is the string. So maybe a student ID, and then the student name, for instance, as demonstrated by line 10. So it works very similar to maps in C++. We also have alias, which is, again, going to be similar to using in C++. All right, again, as mentioned in DLang, strings are an alias for these immutable character arrays. So again, we can't change strings, but that's what we have here. Really interesting feature of D that I simply can't live without now that I've gotten used to it is slices. And slices themselves are a view into memory. So we're thinking again about string view, span, these types of things in C++. But we get those by default with the dynamic arrays in the D language. So I get the view into memory. You can see at line number 9 here, I create something called slice. And I'm just taking a slice from 0, the first element, to, well, 4 is not included here, so the whole array here. Well, you could just take part of it or so on. Again, the slice is not owning that actual memory. So again, same sort of semantics in C++ when we think about string views, but we can read into that data. We can also do operations like concatenate them and so on. If we want to make a copy, we can just use the dup, DUP function showed at line number 20 to just get our own copy if we do want to actually mutate and preserve that change. All right, getting into ranges. Indeed, they pretty much took a pivot when they were designing it. They don't really have the iterator model. Now, of course, you can implement iterators, right? Just a pointer. Or some folks have made different libraries based off of cursors, the same sort of idea of having a begin and an end pointer. But D leaned into ranges. So you've got range-based for loops by default. So for each underscore reverse, and then just looking through the elements. You can use similar things like structured bindings if you've got two different types here for like a key and a value, for instance, in a map. So that's no problem there. So D, again, is fully put their standard library into ranges. Okay, so with that, D itself, those are kind of the language features, hopefully getting kind of interesting. And maybe just as an observation, you could see that it's got a lot of the features that C++ 11 and beyond has had for a while. So again, should be kind of familiar, but you're defaulted into them by default. Now, again, what makes D sort of stretch different domains and interesting is the different paradigms that it supports. So some of these slides, again, I'll go through quick. I don't need to explain object-oriented programming to you. But there are a few interesting things in this language that, again, make you think about how you use your daily programming language. So, of course, we've got structs, which is a way to structure our data. But structs are known as value types in the D language. So again, if you're coming from, say, a C# world, there is a difference between a struct and a class. So structs themselves are a value type. You don't have inheritance. And they're stack allocated by default because they're a value type. Okay. So the type is final. Again, no polymorphism with it. So it's just truly using the structure as a data or like a record in other languages. This I like overall. It makes you make a design decision up front. Now, of course, it's very easy to just change the keyword struct to class. You can do that, no problem. You still have constructors, destructors, member functions, all that sort of stuff, operator overloading, and so on. But again, it makes a clear documented use case of how you're going to actually use that value here. So in this example, I have a struct for a student. There's not going to be any polymorphism there or any guesswork. Classes, on the other hand, are references, are a reference type. So this means that they're dynamically allocated. You allocate them on the heap, and they'll be garbage collected later. Or if you malloc them yourself, then you'll release them when you decide. You have single inheritance for classes, so there's no multiple inheritance. But you do have interfaces, as I'll show in the next few slides here, for if you want to create some derived type from multiple interfaces. So again, in most languages, or in C++, I should say, there's no real change between struct and class other than the default privacy levels with inheritance and the members. But in D, that is an important distinguishment for if you're stack allocating or heap allocating something by default, or if you want inheritance. And here are just a few examples of you can have interfaces, same as in Java. So at line 4, I have interface for an animal that can walk, talk, and eat. And you can have final member functions if you want that are included from anything that derives from animal. So at line 19, it's a little bit small. I have a dog deriving from that type there. So again, interfaces are just the equivalent in C++. You have class with all purely virtual functions, right, set to 0. We do have abstract classes as well in D, the difference being that you can use or add member functions to them. That's the only difference. Most folks end up just using interfaces, but if you do want some sort of base class or an abstract class, you can set that up as well. And here's just another example of abstract class, same as before. Now getting into other paradigms, just in the standard library, D has things like filter, map, reduce. If you're using map reduce or this type of paradigm, you have that available. Again, you can do things cleanly. So the same rules that apply in the C++ world, this idea of no raw loops, you can apply those in D just as well. So this is often an exercise I go through, and it's a great way to actually learn the language or any language that you're studying, is to try to dig through the standard library and figure out, well, how do I get this to a one-liner, right? And you can do this often cases with the universal function call syntax. A question, yeah.
Yes, big question. So it's so nice with when you
Yeah, thanks. So when you have one collection, it's really easy to replace these loops, right? But it gets interesting with multiple collections. So my question would be, is there a nice way, like a zip or something that can do that?
Yep. Yeah, so we have zip in the standard library. If you want to create pairs, we have things like chaining, for instance. So if you have two collections that you want to create pairs of elements and then run some of that.
And it's also cheap, like it doesn't copy, but it's kind of,
Correct.
it's as cheap as an index loop, basically.
As cheap, correct. Yeah, shouldn't be any cost. The ranges, also, again, acting or the ideal with ranges is that they're being evaluated lazily as well. Or if you have infinite ranges, that's again another reason to kind of lean into ranges. So if you're just pushing data or downloading and streaming in data, there's no problem, again, with having a range, zipping together multiple collections and then operating on it. I think I'm going to show another slide too. Another little interesting trick is with these universal function call syntax, we can actually do dot parallel as well if you're thinking about performance, and which is, again, pretty much equivalent to the execution policies in C++ as a parameter. So you get those very trivial to use. So it's very nice, very clean. And in some of these examples, it might have been interesting to, well, kind of gives away, but to ask you, what language does this look like? In my mind, this looks very Pythonic or almost Ruby-like if you've had experience with those languages. So it just reads nicely. All right, so there's mapped. Here's filter. I think we get the idea with the universal loop, but you could do this sort of as some examples here, and then reduce as well. And then to answer the question that was asked, which code has fewer branches, fewer decisions? Ideally, they should be the same performance. Excellent, excellent. Okay, so I think I got one more topic, and then we're going to get into some language stuff and takeaways here. But templates are a big part of the D programming language. So as we know, one of the benefits of templates to avoid us having to rewrite the function. Right? So in this example, I'm showing add integers, add floats. No, we don't like that. So let's use function overloading. So again, also supported in D. It'll choose the right or deduce the right function to call from the parameters. So again, I think there's a talk going on concurrently right now with class template argument deduction. So D can do that with classes, and with functions, it has a implicit, these fun acronyms, but implicit function template instantiation for calling the right type here. So anyways, what we probably really want, instead of redefining this add function over and over and over again, is to write a template here. So of course, your sort of introduction to templates, line 4 through 6, as we saw, is a add function here. Again, this type here, probably want to change that to auto, so it'll deduce the common type that we have available, and it'll return the right type here. Of course, you can have multiple template type parameters. So that's all I'm updating here at line 4 here. You can have T1, T2, and so on. And if you have multiple, then it's to use the types add exclamation point, again, no angular brackets, and then the parentheses of the template parameters that you want to supply. Okay, so here's a few examples here. Template specialization is also allowed, as mentioned, so if you have different types. And then, of course, you can add different template constraints or concepts. Again, just a really powerful part of the library, again, from a traits library. So if you're doing similar stuff to this in C++, this might be one of the, if I'm picking something, again, to one of the earlier questions about where does D potentially displace things, it's with the ease of doing template programming or metaprogramming. It's just a very clean, readable syntax, and the traits library is quite rich in the different things that you can do. Again, things you can do in C++ as well, but just a little bit cleaner. And that's going to be one of the takeaways we'll see here is I usually learn how to do it in D first, and then I take that into C++. So again, you learn from one language and apply to the other, but you see if something's possible, and then you can approach it. Okay, so here's just some more syntax examples of template specialization, specifying the types. So again, I'll move forward from that. And of course, you can have templates for structs and classes, which again might be a classic use case of templates. So again, getting back to one of the superpowers of D is generating code. So just understanding what this code lowers into. Line 5 through 7, this struct here that's templated. Line 12, we instantiate it with an int. And we can see the int type that's instantiated below from lines 33 through 39 here. So this will actually create a template block for that particular type. Now, where things start to get interesting again with metaprogramming is this idea of a feature called a mixin. Just by show of hands, how many folks have heard of mixins before? Okay, probably more than half the audience here. Great. So 78% of our in-person audience or so. But basically, a mixin is just mixing in literal source code. Sounds like a kind of silly feature. You'd say, well, why don't I just write or type out the code? But when you combine this with tools or when you're generating code, it actually becomes quite nice here. So here's, a little member function here where I could mix in a, print data that prints out all the values of this dynamic array here, for instance. We don't have to put that into a string. But effectively, you could think about this like a preprocessor. There's no preprocessor in D, which, again, I find keeps things relatively clean. You do things through the templates. But this basically just mixes in this member function here. Now, what's kind of neat here is with mixins, again, if we're just pasting in code, similar to how you would think of it in a preprocessor, but this is stronger. This is going to be type checked with the actual compiler. The idea is I could just have this, what I'm showing on the left side, and you don't have to read the code here, but it's that entire struct with its member functions, all of that text, and then I can just import it. So I could just do a mixin and import. So what's neat about this is, again, you can pull in pieces of code. You could construct types at compile time by pulling in different text files. How many folks have seen embed in C23? Has anybody seen that? Okay, 2 or 3 folks. This is going to be one of the superpowers of D, learning about this feature of just grabbing a text file and popping it into your code. What's neat about that is if you have some data that you want to embed into an executable, you just pass it in as a mixin. Right? This is like having static data in your executable, so it makes things quite clean and easy to use here. I'll show you some more examples here. So here's a small struct here from lines 27 through 32. It's called some type. I've got an integer field and a float field. And then I'm actually going to mix in something here. So again, mix-ins don't have to be just about copying and pasting in text code, but we can mix in this generate getter setter function here. And I've also templated that function here on some type here. And then I'll pass in true and true. Okay, so I've added in some parameters here. But what we want to know about this, or what we've seen from mixins, is it's just a way to paste in some code here. Generate getter or setter is going to, again, use this traits library to look at all the fields of this struct and just generate the int field and float field, getter and setter functions. Now, just as a little example here. I'll show you what it looks like. You can kind of study it on your own here, but I'll just draw your attention to line 14. I've got a static for each loop. Again, I just want to show you some of the superpowers today, but static for each. So this is happening at compile time. I'm looking at, with this range-based loop, a tuple for the type. Okay, so my type is whatever that struct is. And I get back all the fields of that type, and then I'm going to mix in some code, right, through some for each loop. So for every member, I'm going to mix in a getter and setter function. Okay, so this is just really nice because, again, if you want to generate a lot of types or construct things from configuration files, you can just do this kind of stuff, which I find quite magical. And in fact, I was always impressed when folks would show this in C++, but I couldn't. It was always a bit of a head scratcher for me to actually do. But then I saw in D it was relatively clear. Yeah, question.
That's real. Well, all right. The code was very by itself.
Yeah, so the question was, this has to be done at compile time? Yeah, this is being done at compile time, correct. Now, there's nothing that stops you from, and this is where the game folks like to work and build like a reload system and reload the code as a plugin. You could certainly do that. That requires a little bit more work and engineering. There's no, so you get the static like reflection that you can do at compile time, but no at runtime where you can generate code. Again, can't do that. But those would be nice features. Those are cool things. So anyways, here's a full example. You can dig through it in the slides just if you want to see how to generate getter and setter functions so you never have to do that again. D also has properties so you can access fields like functions. So, that's another option. But anyways, all right. So anyway, that's just a little aside on metaprogramming. Okay, so some other things in D. I know I've taken you through the gauntlet of the language or a big chunk of it. So thanks for your patience there. I'm gonna again get us into some more high-level ecosystem things that are neat. But compile time features. Again, we're seeing this in languages like C++, C++ 23, 26, where every time I look on CPP reference, more and more functions are const expr, so we can do things like compile time. D by default, as well as other languages, just try to evaluate any function at compile time if it will evaluate. So again, that's where these things like pure functions are very useful. And again, picking up some of those ideas. If there's no side effects on the program, we can just evaluate it at compile time. No computation paid. With threading and safety for D, everything in D is thread private or uses thread local storage. So again, something that they were thinking a little bit ahead on for concurrent programming. Right? I think it was Herb Sutter's article, I think it was in 2001 on Dr. Dobbs, of there's going to be no free lunch for concurrent programming, right? This idea that we'll have to understand what's going on. The nice thing is, again, D pushes us a few steps closer there. Otherwise, D has a stood concurrency import similar to thread, where you can do thread-based concurrency. You've also got things like message passing built in, so objects can just send and receive, again, as another way for different threads or different objects and different threads to communicate. In D, there is a safe subset called safe D, so you can read about that. And there are whispers of a certified D compiler and these sort of things. Again, thinking about different Ds being used in the auto industry in different areas where they're thinking about that. So anyways, there's much more to cover here. But again, this is like a full semester's worth of stuff. So we're going to get to part 3 because you've been very patient with that sort of rather comprehensive introduction there. So how does C++ and the D language complement each other? Because that's what we want to kind of get into. So that was a claim or some hypothesis that learning another language is a good idea. Right? We sort of get excited about all these features. Let's actually talk about some of them. And it's not just a one-sided argument, again, for D, but C++ has complemented my D programming. So again, this is from my perspective. Both languages are evolving. Both are large and growing, it seems. Overall, that tends to be a good thing. It does require time to achieve some sense of mastery, I suppose, by learning both languages together and side by side. But let's talk about a few of these things here. So from the C++ perspective, how's that improved my D programming? Well, C++ itself is performance-minded, right? So we're always sort of opting into performance first. And I love being able to use a tool like Compiler Explorer or my compilers to dump out the generated assembly and see what the instructions are doing. That's a lot easier to do in languages that are like C++ or C, for instance. D does have a runtime. It does have a garbage collector. So again, if you're not doing everything manually, you could still do that same dump out of the assembly, but that's something that I've learned from C++ how to do. And again, to think about it in the D language. So you can go to Compiler Explorer and switch to the D language if you want there. D, on the other hand, has improved my C++ just being a little bit more security minded. Now, again, even though I'm coming from sort of a graphics background, it makes me think about some of these things. But this idea of how we initialize memory, and as I mentioned, D gets the defaults right, in my opinion, by default initializing stuff. But you can, of course, opt out of it, equals void. So I'm really curious to see what happens, and that's going to be maybe part of discussions that go on, if we'll get a way to zero initialize objects either by default. I know there were some proposals previously. We'll see what happens. But in D, it was interesting to see a similar proposal with equals void to memory. Now, of course, I've got the guideline here on the top right. There are reasons, again, for performance why you don't want to default initialize, right? If you're going to allocate a huge buffer and then just fill it up right away, there's no sense in double allocating it, right? So anyways, that's just something to think about on the performance side and security. On the C++ side, again, we're always, by default, we're carrying the C language within C++, right? This ability to interrupt with C code. So the ability to work with C libraries, these types of things are something that I'm used to interfacing with C, for instance. So that's really helped my deprogramming and just understanding how the bindings sort of work here. Now, as I mentioned before, the D language has a compiler, a fully built-in compiler. It even handles weird, I shouldn't say weird, but many extensions that compilers provide that you don't think of as the standard language, for instance. So again, that's Walter Bright working, hard on this project and being an expert. But that way you can just, again, read in a C function file as demonstrated here, just import it as a regular .c file that you're compiling and use it. Right? So you can really use the D compiler as a better C and then take advantage of maybe some of these nice features, like if you want lambdas and so on in the C language or slicing or these different ideas here. Thinking about a few things like, again, from C++, we default into vector. So all that knowledge of vector is useful, beneficial to the default dynamic array. So you don't want to forget about things like if you create a dynamic array in the D language and concatenate, right, you can still use things like .length to reserve memory in the D language. Okay, so we don't want to forget some of those tricks as well. In C++, trusting the STL, which I think has been echoed at many conferences, this one included, which I had to learn as a young programmer, to trust tested algorithms and use them as building blocks has been particularly valuable. If there's one place or a piece of advice I can give new programmers who are watching this now or in the future is to actually lean into algorithms. Now, of course, in your domain, if you need to get performance or specialize, you'll do that. But understanding what the blocks are and maybe getting in the habit and removing loops to try to write nice correct code, I think is one area where you can grow a lot as a programmer versus brute force, trying to do things with for loops and reinventing everything. It's nice to think at a little bit of a higher level of that abstraction. So that's something I learned from C++ that I could immediately dive into the D language. C++ has a particular advantage in that it's been around for a long time. It's been well documented. You'll find many authors of books at this conference who've written about the STL and how to use it, which I think is a great thing. On the D language side, thinking about how it might improve C++, and this is maybe a hope and what I'm starting to see in C++ 26 and other further proposals is to have some trust in the standard library. As I mentioned, D has a larger standard library with things like zipping files. It's got SIMD, for getting performance. It's even got a memory mapped library there. Again, more performance things. Working with JSON files, some things that you just want to have out of the box. Of course, you can always grab from the package manager, but these are some things that might be interesting for C++ to think about. And I think we're going to hear more about that with the different networking proposals that are coming in and so on in C++ in the future here. I really like slices in the deprogramming language, as I mentioned. And again, in C++, we have these as spans and string views, but it took me working in the D language to really understand what it means to own or not own something. And again, just kind of keep that straight in my head. Just take some practice. But again, working in a language where that's sort of the default idiom is very useful. Again, as I mentioned earlier when talking about some of the object-oriented stuff, the distinguishment between struct and class, this is in C++ a stylistic choice many times, which you use. I tend to treat my C++ structs as plain old data types or pod data structures. Again, I just find that as a helpful signal. So it's something you might consider in your style guide. But working and thinking in D, that's affected my C++. D uses ranges by default. And again, to be honest, this was something that was quite nice. In fact, the interface for writing a iterator or a way to iterate through a range in the D is quite nice. You need three things. You need an empty either function or something that determines if the range is empty or not. You need a front, so you can look at the first element, and you need a pop front, so you can move forward. And that's it. And to be honest, as I started writing iterators in D, that made it less scary to try to understand the different categories and things in C++, all the different types, to be honest. So I was just moving at a higher level of abstraction so that I could move lower. Again, something that you might consider as you're working in different languages. And then it also made me appreciate some of these benefits, as we mentioned in the questions about infinite ranges and handling and evaluating algorithms lazily with ranges. Generally speaking, ranges are going to be a little bit more safe. It's less likely you pass in two invalid iterators or two pairs that don't match. Again, you could, and you can still get iterator invalidation in ranges in both languages, but it's just a little bit harder. Universal function call syntax. Again, I've mentioned how much I like this, so I don't need to keep mentioning it. We'll keep moving on here. Mix-ins, again, just have to emphasize that I hope we get something like this in C++ for embed, to just be able to bring in code, and it's a really nice way to, if you need to embed resources. C23 has it. I don't know exactly the story of C++, but I imagine we'll get a std embed maybe. And again, the defaults, D has had 30 plus years to catch up and watch what C was doing. So initializing values, and these are things that we want to make habit, okay? All right, getting into some other interesting stuff here. D has contracts. So keeping an eye on, exactly about 3.5 hours from now, Timur is going to be talking about contracts in C++. So get a little bit of a preview of what that looks like. But D has in and out statements that you can put. So just like we put the template constraint, as it's demonstrated, you can have in and out blocks as well. For conditions, it must be true when you enter a function and what must be true when you exit a function. So you can have assertions or static assertions there as needed. So again, just another nice feature I think I'm going to learn from D. I think maybe folks are even being influenced potentially in the proposals. But again, we'll find out in 3.5 hours here. Okay. And there's lots of other little things here. As I mentioned, type of, just read better than decal type. So again, you could just kind of understand these things. Template constraint is just a little bit more clean or clear to me than telling someone what's a concept, because that's kind of an overloaded English word. So if you're maybe telling someone, oh, it's a constraint on the template, that's kind of a nice way to think about things. But on the C++ side, I didn't really understand D's delegates, or it was perhaps easier for me to understand delegates in D by understanding what functors are in C++, right? These objects that carry state and are callable. And then that's how lambdas are implemented and so on. So these are just some little things, again, working in another language that benefited my D. Other big things with the D language and garbage collection. People are very afraid of garbage collection, and in your domain, you might that might be true, right? But it is nice to have safety effectively for free with a garbage collection. You don't have to use it, I think, which is the important takeaway. And it's interesting to see C++, game engines, a domain where stop the world collections and so on aren't really a great option. Still use garbage collections. I'm still waiting for someone to answer my tweet. So this is, why are they using garbage collection when everyone says it's really bad? So someone will answer maybe. The other big things, again, with D, I love the module system. In C++, as soon as the compilers have a import stood standard I/O supported across all the compilers. I think Microsoft Visual Studio is the one that's most reliable, but that really has improved compilation speed. Again, D's compilation speed is very fast, makes iteration time very, very nice. And then const expr. Again, as mentioned, on the D side, I've gotten so used to evaluating functions at compile time that in C++, I'm always looking and saying, why isn't this const expr? There might be very good reason why, but it's something that I'm always looking for and wondering about. There's other little things too. D has built-in unit test blocks, just these little tools. It's not a very high-powered system. You can build on top of it using some introspective capabilities, but having low-friction features is something interesting to consider in the C++ language. There's going to be some more testing talks again on Friday, so maybe we'll learn more. But as far as my C++ goes, I'm just going to grab the most popular tool these days to lower friction if it's not built into the language, which is my takeaway on the ecosystem. There's all sorts of other cool stuff. D has built-in package managers. It's got a built-in profiler. You can profile for allocations as well as performance. It's got a code coverage tool for your tests. You can use the static analyzers and so on. And those are all things that I've learned from various tools in the C++ ecosystem, which is a huge part of why C++, why I taught software engineering, in fact, a lot in C++, because you had to put tools together to complete things. And C++ has a very vast ecosystem. All right, so I'm going to kind of start wrapping us up, and then we'll have time for more questions before lunch, as I stand before you in lunch. If you're going to search for a D language, search for Dlang. You'll get better results. The D language tour, don't forget about your homework that you can do for an hour. There's some nice guides, too, for understanding the D language from various languages. Again, C++, C. There's also interfaces to Objective-C as well, which I didn't talk about here. All the books are good because being a smaller language, the folks that are going to write a book about a small language are going to be, enthusiastic and put a lot of care into that craft. The free book is the one on the left there by Ali Trelli, and I really like Mike Parker's book too. It's a great book if you're a C++ programmer to start from. YouTube, you can check it out. I've got about 100 videos. C++, I've got even more, so check them out. But teaching the D language has been interesting. So you can hear my perspective. Even better, you can hear students' perspective. I just told them to be honest, so you can hear from their words in the second half of that talk. They said what they liked and didn't like, which was great. And you can also look back on my ACCU to hear about teaching C++ as well and how I think about that. So more resources if you're really interested in that side of things. So, just some anecdotal findings, my own here to wrap things up. I think working in a programming language with different defaults, that's probably a top factor in how you improve a programmer's capabilities. Again, I think if there's something I can try to measure, choosing a vastly different language can be very useful for, again, thinking about how you approach different problems. I wouldn't say D and C++ are that vastly different, but there are enough different things in there to make it interesting. So, choose two languages as you will. And even just simply working with a language with a different standard library might improve your capabilities. Right? I didn't know or think about things like zip and fold and chain and all these different things, but they're very prevalent in D code. So you just kind of pick up those things, which is nice. And if anybody wants to run this type of study, I'm in my academic job forever, I think. So feel free to talk to me here. All right, so don't forget your homework. Set your timer for 1 hour. Check out the D language tour. Try it out. See what you learn. See if it improves your C++ or whatever language you're using. All right, with that, we'll take any more questions. Thank you.